Hello and welcome to another video. In this one, we're going to be talking about monkey patching. I'm going to define what it is. I'm going to show you some examples, why you might use this, although I would strongly encourage against it whenever possible. And then I'm going to show you one sort of silly example with it. So what is monkey patching? Especially in dynamic scripting language, programming languages. Monkey patching is the concept of changing some other runtime system at runtime by patching its code. For instance, if you had, I don't know, well, we'll use the subprocess module later to demo this as well. But you might imagine something like this where the subprocess module doesn't work how you want it to. And so you can change how it works. So for instance, normally if you do subprocess.check call, or I don't know, let's use check output. Echo hi. This is run the echo executable, and we're gonna get the byte string hi with a new line at the end. But maybe you didn't want check output to work that way. You can reassign it to something else. I don't know. And let's maybe return hello hello instead. So now check output doesn't work as it did before. It's always going to produce this particular value here. This might seem like a bad idea, and generally it is, but there are a few cases where you might want to do this. One of these might be that you're using a third-party library that has a bug in it, and you want to fix the bug in that third-party library. You may find the particular function that has the problem in it, rewrite its code such that it is fixed, and then modify that module directly so that it has the fixed code inside of it. You may also use this as a quick way to patch a security issue in a third-party library, or sometimes even in the standard library, by reassigning this function. And kind of the third use is during tests, where it may be useful to pretend that a function works in a particular way, even though it doesn't do that. For instance, if you want to avoid some sort of side effect, like making a network call, writing to disk, or launching a missile, or whatever dangerous side effect, you may want to temporarily disable how a function works, such that you can test the system and not bother testing its side effects. And so those are kind of the uses for monkey patching something. Now, there are quite a few caveats here. Notably, you're sort of rewriting the code of a module that you don't own, and so you don't necessarily have the same amount of knowledge in writing that code, and so you may be making a mistake when doing this. If you monkey patch a library and then upgrade it later, you may have broken some of the expectations of the library. I mean, you may have broken some expectations of the library in the first place, but especially as upgrading, you may have changed some internals that don't align with how the maintainer of the library expected them to work. And so you may end up in a situation where the code just doesn't work at all. You may have also patched in a function that got a feature later, and then you need to go, re-merge or patch or make sure that you're still accompanying the future changes in that library. There's a lot of things that can kind of go wrong with, forcibly patching something at runtime that is externally managed. And so generally you want to keep these patches to a minimum, or in my opinion, fork the library, add your feature there, and then use the library without patching it at runtime. The other thing that's a little fidgety about patching at runtime is if something has already imported the function that you're trying to patch, it won't see your visible patches. So like if we try the same example again and say like module B had done from subprocess import check output, and check output works with this. Note that I'm using a from import here. There's a subtle difference between the from import and the module import, which I'll talk about in a bit. But you'll see that check output works like this. If somebody had then in a different module imported subprocess and done subprocess.check output, actually we can just control R, right? Yeah, we can just reassign check output here. Note that check output that we from imported earlier is still unpatched. And so you have to be really careful with patching your modules such that you do it early enough in the process that can affect everything else in your program. I've Googled monkey patching just to make sure that I was trying to see where the name came from, and there's not really a very obvious name source, so I didn't include that part in the video, although now it is in the video, so you win some, you lose some. what many people do with monkey patching is to do it as early as possible, and so often that means, where's init.py? Often that means putting it into some module that's going to get loaded before any other module in your system. This is my previous work, which now has more monkey patches in here, I guess, or more code in here. Oh yeah. Yeah. Okay. So what Sentry does is it's double under init.py. Obviously, these ones aren't very patchable, which hopefully you don't need to do this. This must import first. I wonder. Wait, what? That comment is clearly orphaned. What did it used to do? Import checker. Oh right, I deleted this thing. That's funny. This must import first. No, it's just left behind. Anyway, Sentry has its own monkey patch system that is run as part of actually, this is actually probably a great example for this video, to find some examples that do this for real, although I think I've deleted most of them. So here is like adding some URL schemes to URL lib. This is to fix, this is typing stuff. This is to fix generic classes such that they are actually generic at runtime by setting class double under get item, so that you can do, for instance, like list int is a generic, and this is implemented using list.class get item. But if classes don't have that, for instance, we just make a random class, we can't make it generic unless we assign class get item to this, which is what this does. So for instance, c.that equals this. We've monkey patched class C, and now it does support generics. Of course, it doesn't support them as nicely as, you know, the built-ins too, but it was enough to make it work at runtime, which was the important part. Anyway, so this is an example of some monkey patches you might want. Now, I wanted to talk about this from import thing because I think it's a little bit fiddly. Actually, you know what? I'll save this for another video. Leave a comment in the comments if you understand how this works and can explain it well. But I'll explain this in another video because I think it comes up a lot in testing, and I think it deserves its own topic. But last, let's talk about kind of like how you would do this under test and like how you would safely monkey patch and unmonkey patch something. I'm going to show you the bad way first and then the better way after. So let's imagine that we're just going to use subprocess because whatever. Let's make, this is not a function that I would ever write, but file contents. Obviously you would just use open, but I don't know, whatever. We're gonna use cat because why not? Return, check output, cat. And obviously cat is usually not what you want, but anyway, let's imagine that we have this function. Just to show that it works, we'll just make a little main function. Main, do. And sure, we'll print our own contents because what am I doing? How do I write code anymore? Here, you can see that it is able to print its own contents. Hooray! But maybe we wanted to write a test for this. Let's install PyTest. And yeah, normally you'd write your test in a separate file, but it's going to be, I'm just going to do it in the current file because it's simple enough. Test file contents. And maybe for whatever reason, you didn't want to write out a temporary directory and write out a file. You just wanted to pretend like this works correctly. And so you might monkey patch subprocess. You might say subprocess.check output equals, well, maybe you would, well, let's do it the really bad way first. Then let's do it a correct way. And then let's do a simpler way using a testing utility. So subprocess.check output equals lambda star a star k to byte string file contents, and then you might say assert file contents hello.py equals file contents. This might be a test that passes by doing this. Now you'll notice here that we never reassigned this back, and so if you had written another test, we've sort of leaked this monkey patch to the rest of the program. So if we did assert, maybe this test is written correctly. We have like a temp path join path t.txt. We put some real contents in here. Assert, yeah, assert file contents t is equal to hello. So we have this real test that really actually writes a file and then tests its contents. And if we run this test on its own, it's going to pass. But you'll notice if we run both of those tests, that monkey patch actually leaked out, and so we've broken this other test. We've leaked a patch to the world, and so generally it's a best practice to make sure you clean up your patches after the fact. If you wanted to do that manually, so this is the bad way. This is the okay but not as good as it could be way, where you get the original .check output, and then you would try finally around this, and then do subprocess.check output equals original. So this is kind of like the manual way to undo a monkey patch. Obviously, you know, a little bit clunky, but it turns out there is a standard library module called unittest.mock, and you can use the context manager to do this exact thing directly. Oops. Put that window back to the right size. And so you can say with mock.patch.object, and I'll probably do another video about this specific helper. I strongly recommend always using mock patch object. There is also mock patch, and it has some problems, in my opinion, but this ensures that you're always targeting exactly what you want and undoes it in the right order. So we can just say return value equals this, and it's going to go off the screen, but just trust that it's there. I guess we can reindent it. Yeah, sure, why not? Sure, why not? And now we don't need to do all this try finally stuff. We've temporarily patched this. Oh, I can't see it because it's behind my head. Okay, we will tab it out then. There we go. So what this is going to do is it's going to patch the check output attribute of the subprocess object with a mock object that returns this particular hard-coded thing here. And then when this context manager exits, it's going to undo that patch. So this is only going to be live while this is indented, and so both of these tests will now pass again. But anyway, that's kind of just like the way that you would patch something under test. Obviously, this is a sort of useless function, and this is sort of the useless patch, but I wanted to demo a way to monkey patch in Python. Anyway, hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.